All right, let's talk about something that's gone from a philosophical debate to a straight-up engineering problem: AI safety. We throw around these big words, like responsibility, alignment, safety, but what does it actually look like when you're staring at your code editor? How do we take those ideas and turn them into real working systems? Well, that's exactly what we're going to do today. We're going to roll up our sleeves and actually build it. So let's get into it. I mean, this is the real question, right? It's what keeps developers up at night. We've created these incredible models that feel like magic. They can write poetry, they can debug our code, they can explain quantum physics. But that same creative power has this inherent unpredictability. So what are the actual practical things, the digital seatbelts and the airbags, that we can build to keep this amazing engine helpful and stop it from becoming harmful? That is the engineering challenge we are going to solve together right now. So here's our game plan. First, we're going to really understand the core problem, the unpredictable nature of AI. Then, we'll put on our architect hats and design a solid blueprint for a safety system. After that, the really fun part. We're going to do a hands-on implementation and walk through the actual code. Then, we'll get to see the pretty dramatic impact of our work with a direct before and after. And finally, we'll look ahead, because this kind of work is never really finished. Okay, let's get right to the heart of it. Large language models, at their core, are just incredibly sophisticated next word predictors. That's where all the magic comes from. If you type "the sky is," it's going to predict blue with a really high probability. But it also knows that it could say falling or full of stars. And that ability to navigate this almost infinite space of possibilities is what makes them so creative. But it's also exactly why they're unpredictable and why we have to be so deliberate about building in safety. This analogy is actually way deeper than it looks. Think about it. We, the developers, we're not the ones throwing the ball. The user is, with their prompt. And the AI model, that's the ball, just hurtling down the lane. Our job isn't to perfectly control the spin or the path of the ball. Trying to do that would just kill all the creativity. No, our job is to build the bumpers. We define the safe lane of play, making sure that no matter how wild the user's throw is, the ball never, ever ends up in the gutter of a harmful or unsafe output. So, before we write a single line of code, we need a plan. You'd never start building a bridge by just grabbing a welding torch and some steel beams, right? You'd start with a blueprint. It's the exact same thing here. A really solid architectural plan for our guardrails makes sure that the system is not only effective right now, but that it's also robust, it's scalable, and it's easy to update when new challenges pop up. This is where we make all the critical decisions. And this is a key point. We're not just building a single function, we're designing a system. Let's break this down. It works on both inputs, that's the user's prompt, and outputs, that's the AI's response. That is so important. It's a check on both sides of the conversation. And it's enforcing rules to make sure the chat is 1, safe, no harmful stuff; 2, relevant, so your customer service bot doesn't start talking about baking; and 3, appropriate, respecting privacy, keeping the right tone. This definition right here is our North Star. And this is our blueprint. It's an elegant and really powerful 3-step pipeline. Just think of it like a series of gates that every single conversation has to pass through. First up, an input check to catch any obvious problems right at the front door. Second, a policy engine, which is really the brains of the whole operation, applying all of our specific rules. And third, a final output scan, our last line of defense before that response ever gets to the user. Now, let's see how we actually build this. All right, time to get our hands dirty. This is my favorite part, where our diagram on the slide actually turns into working code. We're going to walk through a really straightforward, practical implementation for each of those 3 steps we just designed. This is how you take AI safety from just a concept to a real function in your application. So our first component here is the gatekeeper. The input check is our first line of defense, and it's proactive. Its job is simple, but it's absolutely critical. Find and block obviously bad prompts right away. And this is huge for efficiency too. It saves us the cost of running the very expensive language model on a prompt we were just going to reject anyway. It's just security 101. Validate your inputs as early as you possibly can. Okay, let's look at this Python code. It's super clean and simple. We've got a function, check input, and it takes the user's prompt. Inside, it calls another function, has prohibited keywords. Now, in a real-world system, that helper function would be pretty sophisticated. It would have this carefully curated list of words and phrases that we always want to block, things related to violence or hate speech. If it finds a match, boom, it immediately returns false, and the whole process stops right there. If everything looks okay, it returns true, and the prompt gets to move on to the next stage. Okay, so if the input check is kind of like the bouncer at the club door, the policy engine is the rulebook inside. This is where the real nuance is. It's not just about blocking universally bad stuff. It's about enforcing the specific rules for your application. This is where you decide, what is my AI for? What topics are okay, and what topics are totally out of bounds? This component is truly the heart of the whole Guardrail system. So check this out. We're defining a policy engine class. Now, imagine for a second that before this code even runs, we've used a smaller, faster AI model to classify the user's prompt into a topic, like customer support, or general chit-chat, or maybe financial advice. Our method here, isTopicAllowed, takes that topic. And in this example, our company has a strict rule. Our bot is never, ever allowed to give financial advice because of the liability. So if the topic is financial advice, we just return false. You can see how easy it would be to add more rules to block medical advice or legal advice or anything else that's outside the bot's job description. We're at the final checkpoint. So we've checked the input, we've applied our policies. Why do we even need this last step? Well, because these models can be unpredictable. Even with a perfectly safe prompt, a model could just invent information, what we call hallucinating, or it could accidentally leak sensitive data from its training set. The output scan is our final quality control, our last chance to catch a problem before it actually hits the user. This last function is so critical, especially when it comes to protecting user privacy. The scan output function takes the response that the AI generated, and its main job here is to call another function, redact PII. PII stands for Personally Identifiable Information. We're talking email addresses, phone numbers, anything that could identify a real person. The redact PII function would use smart techniques to find and remove that information, maybe replacing it with something like redacted. This is how we make sure we don't accidentally leak private data. Okay, so we've designed our system, and we've walked through the code for all three parts. But theory is one thing. What does this actually do? What's the real-world impact? Let's look at a super clear, side-by-side comparison to really see the power of the Guardrail system we just built. This is the payoff. And wow, this just perfectly shows the difference. On the left, you've got the before scenario. A dangerous prompt comes in, and the raw model, just trying to be helpful, starts giving a dangerous step-by-step answer. It's a total catastrophic failure. Now look at the right. In our afterworld, that same exact prompt hits our system. Step 1, our check input function immediately flags those keywords. The whole process stops instantly. The big, expensive LLM is never even called. Instead, our system just returns a safe, pre-written refusal. That right there is AI safety in action. It is so satisfying to see our system work that well. But, and this is really important, we have to understand this is not a one-and-done fix. The system we built is a fantastic foundation. It's a version 1.0 of our safety architecture. But the world of AI moves fast. New models come out, new ways to misuse them are discovered. Responsible AI development is a continuous process of learning, refining, and adapting. So as we wrap up, what are the big lessons here? First, and I think this is the most important, Guardrails make AI safety tangible. It's not an abstract goal anymore, it's a concrete engineering task. Second, that simple three-step architecture we built, input check, policy engine, output scan, that's a really powerful pattern you can go use right now. Third, this system gives us, the builders, a critical layer of control over a fundamentally unpredictable model. And finally, just remember that this is a living system. The work of safety means you're always watching, always testing, and always refining. And that leaves us with one last big question to think about. The system we built today is great for handling risks we can define, the known knowns. But the real next frontier is building adaptive systems. How do we design guardrails that can spot and stop new, unforeseen harms as they pop up? Could we actually use AI to monitor AI, looking for strange behavior that no human has written a rule for yet? That is the grand challenge ahead for all of us. Thanks for building with me today.